Hey everyone, this is Tom from Tutor Bros. Today we're going to look at the remainder and factor theorems of polynomial functions. So we'll start with the remainder theorem, which says that if a polynomial f of x is divided by x minus c, then f of c will be the remainder. So that's a lot of information there. So let's just take a look at our first example problem and we'll see how that works. We have a function here, f of x, which is x cubed minus x squared plus 2x plus 4. And then we have a second function, which is a binomial, g of x, which is x minus 2. So our first step here is to take the second term in the binomial, the minus 2. We'll take the opposite of that term, and then we'll plug it into our original function f of x and evaluate it. And that will tell us what the remainder would be if f of x is divided by the binomial g of x. So in this case, the opposite of negative 2 would be 2. So we'll plug that in over here. So f of 2 equals, and then we just put 2 in wherever we see x, 2 cubed minus 2 squared plus 2 times 2 plus 4. And then we'll evaluate that. So f of 2 equals 2 cubed is 8 minus 2 squared is 4 plus 2 times 2, which is 4, and then plus the constant term 4. And then when we evaluate that, 8 minus 4 is 4, plus 4 is 8, plus the other 4 is 12. So if f of x is divided by g of x, then our remainder will be 12. So that's how the remainder theorem works. And with that said, let's try another example problem. We'll start with a new function here, f of x equals, we'll do 3x cubed plus 2x squared minus x plus 3. And in this case, we'll divide it by g of x equals x minus 3. So again, our first step would be to look at the second term in this binomial. This is a minus 3. So we're going to take a positive or plus 3, plug it into the original function, and evaluate. So we'll do f of 3 equals 3 times 3 cubed plus 2 times 3 squared minus 3, and then plus the constant 3. We'll evaluate that. F of 3 equals 3 cubed would be 27 times another 3 would be 81 plus 3 squared would be 9 times 2 would be 18, and then minus 3 plus 3. Right? 81 plus 18 is 99, minus 3 is 96. Add the 3 back on, we're at 99 again. So if we divide f of x by g of x, then our remainder would be 99. Alrighty, and that is the remainder theorem. So let's erase all that. Now we're going to move on to the factor theorem, which is almost identical. We do pretty much the same process, but what the factor theorem tells us is that if we divide a polynomial by x minus c, and f of c is 0, then x minus c would be a factor of that polynomial function. We'll start with another polynomial here. We'll do f of x equals 4x cubed minus 3x squared minus 8x plus 4, and we'll say we're dividing by g of x, which is x minus 2. Alrighty, so same process. We start with the second term in the binomial here. We find the opposite. So instead of a negative 2, we'll use positive or plus 2. So we'll plug that back into our original function here. So f of 2 equals 4 times 2 cubed minus 3 times 2 squared minus 8 times 2 plus 4. And then we'll evaluate that. So f of 2 equals 2 cubed is 8 times 4 is 32 minus 2 squared is 4 times 3 is 12 minus 8 times 2 is 16 and then plus 4. So let's evaluate that. 32 minus 12 is 20 minus 16 is 4 plus 8, or excuse me, plus 4 is going to give us 8. So when we divide f of x by g of x here, our remainder is 8. So since the remainder is not 0, then we know that g of x, which is x minus 2, is not a factor of f of x. So that's what the factor theorem tells us. All right, let's try another example problem together. We'll start with f of x equals 3x to the fourth. So we'll do a fourth degree polynomial minus 6x cubed minus 5x plus 10. And then g of x will be, we'll do x minus 2 again. Alrighty, same thing. We'll take the opposite of the second term in the binomial, plug it into f of x, and evaluate. So opposite of minus 2 again would just be 2. So it's f of 2 equals 3 times 2 to the fourth minus 6 times 2 cubed minus 5 times 2 plus 10. And then we'll evaluate that. F of 2 equals 2 to the fourth is 16 times 3 is 48 minus 2 cubed is 8 times 6 is 48 minus 5 times 2 is 10 and then plus 10. Alrighty. So then 48 minus 48 is 0, minus 10 is negative 10, and then plus 10 would be 0. So our remainder here is 0. So when we divide f of x by g of x in this case, our remainder is 0, which by the factor theorem tells us that g of x is a factor of f of x.